everyone. We're going to graph the polar equation as cissoid. We have r equals sine of theta times tan of theta. So basically we're going to first check for symmetry. And the first test is check with symmetry with respect to the polar axis. And we're going to replace theta with negative theta. So we're going to write r equals sine of negative theta times tan of negative theta. Both of these functions are odd, so we can write this as negative sine of theta times negative tan of theta. Two negatives make a positive, so we're going to get sine of theta times tan of theta. It is an equivalent equation. Since it's equivalent, it means our test passes and our graph is going to be symmetric to the polar axis or the x-axis. Okay, let's also test symmetry with respect to the line theta equals pi divided by 2. And that requires us to replace theta with pi minus theta. So this is going to be sine of pi minus theta times tan of pi minus theta. So I'm going to use these two difference formulas to expand and evaluate. So let's do that. We're going to get this equals a sine of pi cosine of theta minus cosine of pi sine of theta. And this is going to be times, and I'm going to write the times down here. Tan of pi minus tan of theta divided by 1 plus tan of theta, or tan of pi times tan of theta. Now, for the sine part, let's see. Sine of pi is 0. Cosine of pi is negative 1. So when you have two negatives, you're just going to get sine of theta. So that gives you that. Now for this piece, we get, this is going to equal negative tan. This is 0. So we're going to get times negative tan of theta. And this is 0. So this knocks this out and it's divided by 1. Therefore, we have negative sine of theta times tan of theta, which does not give us an equivalent equation. Therefore, our second test here fails. So it's not going to be symmetric to this line. And for the pole test, you just substitute in r for negative r. And clearly, it's not symmetric to the pole. Therefore, since it's only symmetric to our polar axis, we're going to assign values for theta to be between 0 to pi. Alright, so let's do that. I've already assigned from 0 to pi, and we evaluate this, and we're going to get 0. Let me do a different color. And for pi divided by 6, we get 1/2 times square root of 3 divided by 3. This is approximately 0.3. At pi divided by 3, we're going to get 3/2. At pi divided by 2, it's undefined. At 2 pi divided by 3, it's negative 3/2. And at 5 pi divided by 6, it's the same as this one, but it's going to be negative. It's going to, because we're going to have negative square root of 3 divided by 3. So this is going to be negative 0.3. And at pi, we're at 0. So let's go ahead and trace out this curve and then use symmetry to finish it off. At 0, we are at 0. All right, next, pi divided by 6. Let's make this, let's make this go out to, no, I don't think it's that necessary. Okay, I was going to spread this out so you can see it better, but I don't think we need to. So here we are at pi divided by 6 at 0.3. So let's go out a little bit here. At pi divided by 3, it's 1 1/2. And at pi divided by 2, it's going to be undefined. At 2 pi, so it's going to kind of go out this way. But it's never going to cross pi divided by 2. Something like that, I think. All right, let's go for this other part. At 2 pi divided by 3, we're at negative 1 1/2. So that's about right there. And at 5 pi divided by 6, we're at negative 0.3. So that's less than 1. So it's really close in. And at pi, we're at 0. So this is how this is going to go out. So this is what the graph kind of looks like. All right, so let's make it all one color. Oops. And that's it. Thank you. Have a nice day. Bye-bye.